Hello, good day to you. We are students at Bahrain Polytechnic. My name is Muhammad Abdul Jalil and my colleagues are
Amjad Ali,
Faisal Absanat,
Abdul Zuhur.
and we are going to conduct an experiment on fluid properties and pressure. And
in the first stages of making the apparatus for the experiment, we have cutted the jars using cutters and scissors so that one of the jar will be open-ended from both sides. Next, we have drilled 2 holes in order to fit the water pipes, and we made sure that one person is drilling and the other person is holding it firmly. After drilling, we made sure that the holes have a smooth surface, so we used a metal file to do that. The third stage is all about connecting both the plastic jars. We made sure to keep Teflon tape in order to prevent leakage, and then we have used an electrical tape that will make sure that the both jars are connected firmly. After connecting both the jars, some of the measurements were taken, such as the height of the apparatus and the height of the both holes from the ground, which all these readings will be demonstrated in the theoretical part. Cutting 2 pieces of the water pipe, and to be consistent, each one of them is to be 10 centimeters. Moving on with the experiment, we have used an epoxy clay and made sure that it has been mixed very well. And for extra measures, we have used the Teflon tape to prevent the leakage through the holes and the water pipe. Fitting both of the water pipes through the holes, and we applied the epoxy and made sure that it is closely packed. We have repeated the same procedure for the next hole. Last step of making the apparatus of this experiment was blowing up 2 balloons and preventing the air from coming outside with a cloth clips, and finally attaching both the balloons to the water pipes by using Teflon tape and electrical tape.
So you can see that we added the food coloring to the apparatus that we have over here so that we can better see the flow of the water into the balloons. So you can show in the video as well, and we can see in the balloon how much it is being filled up. And as you can see in the first balloon, it actually pushes the air out, and in the second one, it starts filling it up.
Now I'll explain the experiment. So as you can see,
in the experiment, as you saw, that the water actually was able to enter the balloon, but over here the air was able to push it out. The reason is because as you go deeper, the pressure increases. The pressure over at this point was low enough for that air to push the water out and escape. But over here, the water pressure overwhelmed the air pressure over here, and instead of air being able to push out, the water actually pushed it through, and it went and it filled it up inside the balloon.
Now we will derive the pressure formula that we have, which is pressure equals to rho hg. First of all, we take the second laws of Newton, which states that F equals to m times the mass times acceleration of gravity. We can break that the mass itself is equals to density times volume. We sum it up, we have the force equals to density times volume times gravity. To proceed, we have the V equals to, which is the volume of the cylindrical shape, pi r square h. Now we just substitute the V with the formula here we have it here as stated. F equals to pi density r square h times g. Now we have the pressure rule, which states that pressure is equals to force over area. We already have the force, so we just direct substitution of the force, and here we have the pi times r square, which is equals to the area itself. So we just substitute it and we cancel the area together, and now we have the rule of the pressure. The pressure equals to rho hg.
Go.
So the last thing about this experiment is the difficulties faced during conducting the experiment. So during conducting the experiment, actually the first trial has been failed and the second trial was successful. The reasons behind the failure of these is actually linked to the difficulties faced. The first thing is the leakage of the water. As you can see in the second balloon, we kept inserted a clay, however the clay did not attach because we did not give it a time. So there was a leakage in the second balloon. Moreover, the flow of the water. The first failure, which we will be showing you, we kept the hole in the water. So due to the gravity, it cannot flow properly. So that's why in the second experiment, we kept it hanging over the table, and this has solved the problem.
Hello, how are you? My name is Muhammad, and I'll be doing the part on a real life example. As we know from the experiment, or as we conducted from the experiment, we know that the more the depth increases, the pressure increases. And we have a real life example of that is as when we go in scuba diving or diving. It's known, or it is found out through science, that the human body has an internal pressure equaling the atmospheric pressure. However, that pressure does not increase, it stays how it is because normal life stays in normal atmospheric pressure. But when we go diving, we have the pressure of water on top of it, the atmospheric pressure, and we can feel it when we dive, and it increases as we increase the depth. And that's why the maximum limit for safe diving is at 40 limits, since the human body cannot sustain any more pressure and may have any health endangering effects on the human body. Thank you for listening and have a nice day.